There's something lurking out there so massive, it defies physics. A void so big, it could swallow our entire solar system and still have room for seconds. And here's the wildest part. It's real. Some say we've already found the largest black hole in the universe. Others claim we've only scratched the surface. But one thing is clear. These aren't just big cosmic vacuum cleaners. They're ancient, invisible monsters that warp time, bend reality, and rewrite the rules of what's possible. So today, we're diving headfirst into the biggest black holes we've ever discovered. From the fan-favorite TON 618 to the mysterious new contender hiding at the heart of a galaxy cluster that's rewriting the record books. But don't get too comfortable, because by the end of this video, you'll realize something terrifying. The biggest black hole we've ever seen might not even be the biggest one anymore. What even is a black hole? Let's get one thing straight. A black hole isn't a hole. It's not an empty space. And it's definitely not some sci-fi portal to another dimension. Though, honestly, it's almost weirder than that. It's mass, pure mass, compressed so tightly that the rules of space and time start to glitch. Picture this. Take something the size of Earth, crush it until it's the size of a marble. That's how dense we're talking. At a certain point, gravity wins. It pulls so hard that even light can't escape. That invisible edge where nothing returns. It's called the event horizon. And anything that crosses it, gone, forever. No light, no signal, no escape. Black holes aren't just the stuff of doom. They're part of the life cycle of the universe. When massive stars collapse at the end of their lives, they can leave behind these ultra-dense corpses. Some stay small, some grow, some become absolute monsters. And it's those monsters we're here for. Because as scary as a stellar black hole might sound, it's nothing compared to what's coming next. How big do they get? Black holes don't stop at stellar corpses. They grow, they merge, they consume. And given enough time and enough cosmic buffet, they evolve into something far more terrifying. The scale starts small. Stellar black holes, maybe 5, 10, 20 times the mass of our sun. Common, quiet, deadly. Then come the intermediate mass black holes, the weird middle children. A few thousand solar masses found in dense star clusters, maybe born from ancient collisions or even runaway chain reactions in early galaxies. But then, we get serious. Supermassive black holes. These sit at the center of galaxies, millions, even billions of solar masses. The one anchoring our own Milky Way, Sagittarius A star. It weighs in at about 4 million suns. Impressive, sure, but it's barely a footnote compared to what's next. Because once you hit 10 billion solar masses, you enter a realm so absurd, scientists had to invent a new label just to describe it. They call them SLABs, stupendously large black holes. And trust me, the name doesn't even begin to cover it. TON 618, the people's champion. Before TikTok, before smartphones, before anyone knew what a slab even was, there was TON 618. For years, this was the undisputed heavyweight champion of black holes. And get this, when astronomers first spotted it, they didn't even realize what they were looking at. It was so bright, so intense, they thought it was a nearby blue star, just a pretty little glow in the sky. They were wrong. TON 618 is no star. It's a quasar, a blazing beacon of energy powered by a black hole that refuses to stay quiet. The light we see from it today, left over 10 billion years ago. That's right. We're looking at something that happened before Earth even existed. And the numbers? Terrifying. Initial estimates put TON 618's mass at 66 billion suns. That would make it the largest black hole ever discovered, hands down. An event horizon so wide, it could swallow the entire solar system. 40 times over. Now, scientists have walked that number back a little, maybe closer to 40 billion. But honestly, that hasn't stopped the hype. TON 618 has become a legend, shared in Reddit threads, dropped into YouTube black hole comparisons, and featured in every top 10 biggest things in the universe video you've ever clicked at 2 a.m. It's not just massive, it's famous. And for a while, no one came close. Until something strange started stirring in the heart of a galaxy cluster no one saw coming. Enter the Phoenix Cluster, the new challenger. In 2011, deep in the cold silence of Antarctica, scientists using the South Pole Telescope picked up something weird. A cluster of galaxies, about 1,000 of them, blazing with more X-ray radiation than anything they'd ever seen. Buried inside, one galaxy outshined the rest. They called it Phoenix A, and almost immediately, astronomers noticed something didn't add up. See, galaxies that big, especially the ones sitting at the center of massive clusters, aren't usually busy. They're old, quiet, drifting through cosmic retirement. Not Phoenix A. It was a stellar factory, pumping out over 600 new stars a year, hundreds of times faster than our own Milky Way. And at the heart of all that chaos, a sleeping giant. Black holes don't like to share the spotlight. When they feed, they glow. When they erupt, they leave scars. And Phoenix A had scars. 2 enormous X-ray cavities, like punch holes blown through space itself. One of them stretched wider than our entire galaxy. Whatever carved those voids wasn't just big, it was powerful. Astronomers looked closer. They saw signs of a violent outburst, an explosion from the galaxy's core about 100 million years ago. It was enough to shove gas aside, halt star formation. And then, oddly, it stopped. The black hole went dark. That silence is what let Phoenix A light up with new stars, like a forest regrowing after a wildfire. But here's where it gets wild. The eruption that caused those voids, it was so massive. Some scientists started wondering, what if the black hole behind it wasn't just big, but the biggest one we've ever seen? The 100 billion mass controversy. In 2015, a team of scientists at the Max Planck Institute dropped a cosmic bomb. Using a new model that analyzed galaxy cluster dynamics and black hole feedback, they estimated the black hole at the center of Phoenix A could be packing a mass of 100 billion suns. Let that settle for a second. That's not just a record. That's twice the theoretical limit, bigger than entire galaxies, nearly 10 times more massive than TON 618. And just like that, Phoenix A star, as it came to be called, was crowned the new largest black hole in the universe. Well, sort of. Here's the thing, that number, that jaw-dropping 100 billion, it wasn't based on direct observation. No telescope peered into the void and measured it. It came from indirect modeling, a theoretical estimate based on how much energy it would take to hollow out those X-ray cavities. In other words, they measured the explosion, then guessed the size of the bomb. It was bold, controversial, and just ambiguous enough for the internet to run wild. Suddenly, Phoenix A star was everywhere. YouTube thumbnails, space forums, viral TikToks. Headlines blared, "New largest black hole found." But in the scientific community, eyebrows raised, because the same study that gave Phoenix A its 100 billion title also gave that same mass to two other black holes, IC 1101 and Holmberg 15A, and both of those have since been revised downward, way downward. Is it real or just hype? Let's cut through the stardust. That 100 billion figure sounds epic, but so far it's held together more by internet hype than hard data. Take IC 1101 for example. Once thought to house the largest black hole thanks to its bloated 6 million light-year wide galaxy. But better measurements put its black hole closer to 40 billion solar masses. Then there's Holmberg 15A. In the early 2000s, estimates had it pushing over 300 billion suns. Nope. Modern observations dialed it way down to the same neighborhood, around 40 billion. That pattern's important because Phoenix A's claim to 100 billion comes from the same study, same method, same assumptions. And here's the kicker. The Phoenix, a black hole, doesn't even behave like it's the biggest. It's not shutting down star formation. It's not heating up its surroundings like a black hole that size should. In fact, some researchers think it might be too small for the cluster it lives in, an underachiever, not an overgrown monster. But here's the thing, we don't know for sure. Not yet. Why? Because measuring these beasts directly is brutally hard. The farther away they are, the fuzzier the data gets. We're stuck with models, guesses, and indirect signs like shockwaves and X-ray bubbles. That's why new methods, like gravitational lensing, which uses warped light to weigh the invisible, are so exciting. Just this year, astronomers used it to peg a black hole in the Abell 1201 galaxy cluster at around 32 billion solar masses, with far more precision than ever before. And that's just the beginning, because if we're already finding giants that size with clear measurements, what else is out there just beyond the blur?